my name is Yashasvi and I'm a senior software engineer at Velotio. This is part 2 of our server sent event tech short, so let's just quickly go into the agenda. In the last part, we saw a basic overview of what server sent events are. We saw a little bit of use cases and examples, and we briefly saw how it works under the hood. In part 2, we are going to be going into that example code and understanding how it works with regards to the APIs that we have in our browser and how we handle it in the server side. Next, we'll do the comparisons with different technologies, let's say, which is polling or, for example, WebSockets. How do they compare with each other, right? And next, finally, we'll talk about the limitations of server-sent events, and we'll be closing it up in our conclusion. So let's just get into it. All right. So we have talked a lot about theoretical concept of server-sent events. Let's just see the small practical example that we saw earlier, how it boils up into the code, right? So there are three pieces to the example that we built. We have to have the server connection bit handled, the client part, which is essentially connecting to the event server sent events, and finally a way to trigger the entire thing so that we can see the entire server sent events working, right? So I had a small component, right? You can see like there is a small component which is basically triggering the events, right? So we can pass in message and we can click on the send button. So here in this trigger component, you'll see that it is nothing but a small API call to this API/trigger endpoint. It's a post request and it's just stringifying the payload, which is essentially the message bit and the event name bit, and that is going to get into the server side, right? Very simple. We have added a small UI bits wherein you can get the notification snack bar and all that, but essentially the entire butter of this entire call is this part where you are making a post request to the server to trigger an event. In the backend side, you'll see that the same thing is handled very elegantly. We are taking out the event name and the message. We are just displaying that message onto the console. And right. So we are just publishing a message onto that subject stream, right? And then we are just returning back for this particular API, right? This is how it's going to be triggered. Now, once that happens, it's about handling the connection in the right side, which is the restaurant bit, if you remember, right? So in order to do that, what we have to do, we are going to be using the event source API, which is the overall or abstraction layer which the browser gives us, which we can use as a developer to start or initiate the connection and start accepting the messages which the servers are sending us or giving us, which can be handled onto the front end, right? So I have a very small use effect, right, in which we are essentially using the event source API and trying to connect to this specific endpoint, API/message. This is the endpoint where the server is listening for all the server sent events connection initialization, right? Once this is successful, we'll be getting the event source object and we are defining certain lifecycle methods on it, which can essentially allow us to handle certain parts of our code, right? So we are saying on the message bit, like whenever there is any kind of message, a generic message without any event name specifically, all we are doing is we are deserializing the data. Remember that data is string based and we need to deserialize it if you're using JSON data, right? If it just has text based data, wherein you are saying hi, hello, or something like that, a simple message, you can just append it to the DOM or do whatever you want. But we are deserializing it because we are dealing with JSON data as we saw it in the triggering bit, right? Once we receive the message, we are doing nothing but basically adding or pushing a notification onto our UI. That is the generic handling of the message. Now, what happens if there is a specific type of event occurring, or when we are specifying an order cancelled or an order created type of event, right? In the triggering part, what we are doing, whenever there is any sort of message which is of different event name, let's say order created or order cancelled, these two, we are sending that same data as a JSON to our server, right, on the triggering endpoint, right? So here as well, what we are saying that when the backend essentially gives me an event which is of matching this particular event type in the event name or this, my callback should handle this on order created and on order cancelled, right? So we are giving the event name and then we are passing the callback, right? So event source will notify it's the job of event source object itself, which is a high level abstraction, right? Which allows us to execute this callback in case when the order cancel event was coming in from the server, and it will execute this specific callback when there is an order created, right? In both the things, we are just doing nothing, but we are just adding more or another object onto the orders state, which is coming in here, right? And as it gets filled up or if it gets added into the array, we are just basically rendering into a card. right? Pretty simple. This is all we need as a bulk of it for handling the event server-side events. And of course, in the cleanup code, we are just saying that if this tab gets closed or this component gets removed from the DOM, we are closing the connection. That's all, right? This is the cleanup bit. Very simple, very easy to implement. Now let's look over onto the server side, how we are implementing the API/message bit, right? Remember we were saying that we need certain headers to be executed or sent back to the front end in order to handle everything, right? This is essentially we are doing the same thing. When we are calling this new event source slash API slash message, what it is essentially doing is creating a GET request to this particular endpoint, right? And there, what we are doing that in the response object, we are setting the cache control to no cache so that we are telling the front end to not cache the responses of this. We are saying that the content type I am going to be sending back as a server is text/event stream, and I want the front end to keep the connection alive, right? This is the contract bit that we were talking about. This res.flush headers is basically essentially doing removing the irrelevant headers which are not needed for this specific case. For example, user agent or something like that, right? Now you see that for each connection that will come in, meaning if more tabs are created on the front end, or let's say some other client gets connected, for each one this will be happening, right? And the connection will be created. So for every connection, what we are doing, we are creating a subscription on that message observable, right? In RxJS, this is an observable. So in the triggering API, we were pushing the message to that observable, and in here we are subscribing to the messages in that observable. So once we receive that subscription, what are we doing? Whenever there is a message, this is a callback, right? Whenever there is a message onto that observable, this specific callback will be called. And here we are doing nothing except giving out the data that is going to be passed to the front end, right? We can create an ID field for our response, server sent event response, right? This is optional, obviously. Then in the next line, we are giving a name optionally, right? If there is a name that exists in the message, we'll add that. Otherwise, I'll be pushing in a generic message type for it. And finally, whatever the message we have gotten from the observable, we are stringifying it and then sending it back to the front end. So essentially, this is what the structure will look when we go into the front end bit, right? And of course, whenever the tab is closing, we are also unsubscribing from the observable just to have a cleanup code. That's all, right? So this is essentially the main bulk of it, right? Now, how do you test out whether this is working or not? When you go to your front end, you will have your inspector ready, right? You go into the network tab. Now, when we click in here, let's say, I don't know, some message, and let's say we say order cancelled, right? When we click upon this, API trigger will get called, and then accordingly, a message will be pushed to the observable, right? So here, when you see here, when I refresh this page, that use effect got called, and this was the API path or endpoint in which server sent event was being handled, right? So you can see that except that we received, request header was text/event stream, which is ideal. Response header is zero yet right now because we have not sent any message from the server to the front end. We have only acknowledged the connection, right? So in here, you can see that the status is still pending, right? So if you open up here, you are not going to see any data that has been coming in because we have not sent any data from the server, right? So let's do one thing. On the left hand side, I'm going to initiate or trigger a message. I sent that, and a new card came up. That means our code is working, right? So now when I click upon this, you can see that status was 200. Double click on it, you'll see that a new event stream tab has come in, right? Now that the data has been sent from the back into the front end, you can see that, okay, so the response headers were no cache, which we did, keep alive, that is also something we did, and essentially the main bit, which is content type, it should be text/event stream, right? Now, the main amazing thing is that you can click on this event stream and all the messages that has came in through this connection, you can observe it, right? Let me just expand this a little bit. This is the exact value that we passed, right? Let's try another one. Let's say new notification, right? I'm not giving any event name, and I click on send. The moment I click on it, I receive a message on my stream, and that is what I see here. Okay, so now let's talk about the server sent event limitations specifically. The first and foremost and most important is the unidirectional communication, meaning the server can only send data to the front end and not the other way around, right? Now, one major drawback is also the binary support. You cannot send binary data or raw bytes from backend to the server. Remember that server sent events are an HTTP-based protocol, and it is specifically meant for low latency, high transmission text-based messages, right? Now, when I say binary support is a limitation, it's not undoable is the reason that you can always convert your binary file into a base64 encoded string, which you can then send it out to the front end. Although it's not recommended, you can do it for small files like few KBs here and there, but when it goes into the megabytes, it is not recommended because it will increase the latency as well as overhead. So yes, binary support is limited here. Another major limitation is the connection limit, meaning how many server sent events connection can be maintained parallelly by the browser. Now, when we talk about this, we have to note that this is not specifically the limitation of the browser itself, but the HTTP version that you have been using into your server and your application connection. So HTTP 1, which is an old spec, doesn't have that much of a flexibility, which can support quite a lot of connections simultaneously. When I talk about simultaneously, it is essentially that you may have opened your product or your software or your web application into multiple tabs inside the same browser, same URL. So every time a new browser tab has opened, it is trying to create a new server-send event connection with your server. So all the 6 tabs, when the server sends an event, all the 6 tabs will receive their data simultaneously, but the limit is 6 in case of HTTP 1.1. When we go into the HTTP version 2, which is secure, has more flexibility, is more robust spec sheet, there you have the upper limit of 100 connections simultaneously. Remember that this connection is per domain. It's not per browser, right? So you can very well have one domain, let's say example1.com, and have 6 tabs open in case of HTTP1, and all that will work fine, along with having another domain, which is, let's say, another project, example2.com, that also, if it is being served using HTTP1, can have a separate 6 connections simultaneously. So total, the browser is obviously able to maintain 12 connections simultaneously. It's the limit on the older browser, like we checked out in the previous slide. Internet Explorer and old versions of Chrome, let's say, or Firefox, those will have a limited support, if at all, for server-sent events that you should be careful about. So this is all about limitations of server. So what are the insights that we have learned from this lecture? Server-sent events is a trivial integration, meaning that it's very easy to implement given that our use case supports it. Simplicity, yes, with minimum overhead, you don't have to be too much about it because it already has features like auto reconnect, developer friendly approach. We saw in the code that it's so easy to implement, right? Wide applicability. As long as you're not dealing with binary data, servers and events can handle any sort of data transmission, given that it is a unidirectional, meaning our use case should support unidirectional, it should be text-based, and it should be for trivial integration. So essentially, if these are the things which is supporting my use case, I should be looking over to server-send events for real-time data transmission, right? So this concludes this tech short on server-send events. I hope that it gave you insights and hopefully you will be able to use it in your next project. Thank you.